Welcome to EDU World Space.
Okay, in this problem we have a mirror and we are given the object distance of 1.7 meters and a magnification of positive, this is important, positive 3. So we will end up with an upright image that's been considerably magnified. So what we need to solve this problem is we need to use the equation for mirrors, 1 over d naught, and lenses. This is mirrors and lenses, ideal. 1 over d naught plus 1 over di, where that's the object distance and the image distance respectively, are equal to 1 over the focal length of the mirror in question. We will need this. We will also need to know, we also need the fact that the focal length is equal to 1/2 the radius of curvature for that mirror. And lastly, we need the definition of magnification. Magnification is defined as the negative 1 over the image distance over the object distance. Well, it's not so much a definition, but this is a way we can calculate it. It's negative the ratio of the distances, but it's also its real definition is the image height to the object height, which happens to be equal to this ratio of distances, which is useful. So combining these three results, we can take the information we have, the object distance, and the magnification, and we can find the image distance and the radius of curvature. So to start, we will use the magnification definition, this third equation here. We have all the information we need, so we can find the image distance, di, equals negative m do. Or for our results, will give us, actually, we don't need that for now. We'll do a little bit of manipulation first. We can use the lens equation to get an expression for f. Bit of algebra. We have d naught di over d naught minus m d naught. So here we can replace di with a more familiar result using this. So in one more step, we would end up with m d naught over m minus 1. Just a tiny bit of substitution there. Finally, we can put in some numbers. We have 3 times 1.7 meters over 3 minus 1, which is, of course, 2. And we end up with a result of 2.55 meters for the focal length. Once we have the focal length, getting the radius of curvature is easy. R is simply equal to 2 times f. So 2 times 2.55 gives us about 5.1 to be more precise. And that's the result. So just to recap what we used the equation for ideal lenses, which you will see a lot in this chapter. We also used the fact that the focal length is always half the radius of curvature, or equivalently, the radius of curvature is 2 times the focal length. And we used the more appropriate way to calculate the magnification using the ratio of distances as opposed to the ratio of heights. Since we were given m and given d naught, we can find everything else we need. And that's it.